Welcome to Learning with Chris. Today's topic of discussion is the elimination method. The elimination method is a method for solving system of equations by adding or subtracting to eliminate a variable. There are 4 steps to solve this type of method. Step 1 is to make sure that your equations are lined up. Then you are going to add or subtract the equations in order to eliminate the variable with common coefficients. Your third step is to solve for the remaining variable, and then lastly, you're going to substitute the answer you get into either of the original equations and then solve for the other variable. So let's start with some examples. Question 1. So we have the system of equation y equals 3x plus 4 and y equals x minus 2. Because our y variables have the same coefficient of 1, we can simply subtract these two equations from one another in order to solve for x. So our y's will cancel out, and then we will be left with 2x plus 6, because a negative minus a negative makes it a positive. So now we will try to isolate our variable by subtracting 6 from both sides, and we will end up with negative 6 equals 2x, meaning that x equals negative 3. Since we now have our x variable, we can plug this back into our original equation and do y equals negative 3 minus 2. Meaning that our y variable is going to be equivalent to negative 5. So our final answer is going to be negative 3, negative 5. Moving on to question 2, we have the system of equation x plus 4y equals 13 and x minus y equals 3. Once again, our x variables have the same coefficient of 1, so we are able to simply just subtract this problem. So by subtracting, our x variables will cancel out, our y variable will become 5y, and our coefficient on the end will become 10. So 5y equals 10 simplifies to y equals 2. Since we now know that our y variable is equal to 2, we can plug this back into our original equation and do x minus 2 equals 3. So adding 2 to both sides shows us that x equals 5. So our final answer is going to be 5, 2. This time, both of our x values have a 3 in front of them, but since they're still the same coefficient, we can simply just subtract the problems from one another. So our x variables will cancel, our y becomes a negative y, and our numbers on the end become negative 1. So negative y equals negative 1 is simply y equals 1. So plugging this back into an equation, we can do 3x minus 10 times 1 equals 14. 3x minus 10 equals 14. 3x equals 24. X equals 8. So our final solution is going to be 8, 1. Moving on to question 4. We see that this time our y's have the same coefficient of 2. So once again, we can just subtract the equations from one another. So our x's are going to become 6x, our y's are going to cancel out, and our integers on the end become negative 12. 6x equals negative 12 is simply x equals negative 2. So now we can plug that back into one of our original equations and do 4 times negative 2 plus 2y equals 6. Negative 8 plus 2y equals 6. Add 8 to both sides, and we get 2y equals 14, meaning that y equals 7. So our final solution is going to be negative 2, 7. Moving on to number 5, we see that our x's have the same value of 4, but our second equation has a negative value of 4. But this is not going to stop us. We can simply add the equations together instead of subtracting them so that we can still get rid of our x variable and solve for y. So now our x's are going to cancel out. Our y's are going to equal 16y, and our integers on the end are going to equal 16. 16y equals 16 simply means y equals 1. We can now plug this back into another equation to do 4x plus 9 times 1 equals 5. 4x plus 9 equals 5. Minus 9 minus 9. 4x equals negative 4, meaning that x equals negative 1. So our final solution to this system is negative 1, 1.